Hi students, today we are discussing about the third application of uniform circular motion. That third application is vehicle on a vehicle on banked road. Vehicle on banked road. Already we take the two applications of uniform circular motion that are on a unbanked road. So what is unbanked road, and this is vehicle on the banked road. First we discuss about what is banked road, or why that word is used here, banked road. So when a vehicle take a turn, suppose that vehicle is taking turn, for the circular motion of that vehicle, the necessary force, that is the centripetal force which is necessary, and in this condition the frictional force Fs, force of static friction, which provides the necessary centripetal force for the circular motion of that vehicle. Already we know that. So already we calculate the frictional force, already we calculate the upper limit of that frictional force, and also its value is usually not constant, as the road is not uniform. If that road is not uniform, therefore the value of frictional force that also not a constant, and that's why in our real life we should not depend upon that frictional force, and that's why the surface of that curved road, that's why the surface of that curved road are tilted with a horizontal with some angle theta. That means this is the horizontal road and this is the small angle theta, that road surface which is tilted with a small angle theta. So this is the road surface. This process, which is called as banking of road, or that road is said to be banked. That means in another way we can say that, suppose this is the inner surface of that road surface and this is the outer surface of that road surface. That means outer surface of the road surface which is raised by a certain angle, that is the theta is the angle, that is this is the inner side of that road surface. That means outer edge of that road surface is raised than its inner surface by a suitable or particular angle. That angle is called as angle of banking. Angle of banking or banking angle. So in this condition we are studying, that is the vehicle on a bank road. So already we know about the what is banked road. That means we take that small angle theta, that is called as angle of banking. So if suppose the vertical section of that vehicle on a curved road of radius r, suppose r is the radius of that curved road, and banked at an angle of theta, theta is the angle for that, with horizontal, consider the vehicle to be at a point ignoring the frictional force or non-conservative force. So in that case, suppose this is vehicle, this is vehicle. In this condition, in that banked road, the various forces act on that vehicle. The first force which is act in downward direction, that force is mg, that is the weight of the vehicle which is act on that, which is in downward direction, mg is in downward direction. And the second force exerted on that vehicle which is perpendicular to this banked road surface, that means that is a normal reaction, n is n normal reaction, and that normal reaction which is perpendicular to this banked road surface. Now this normal reaction which is resolved into two mutually perpendicular component. First component, that is vertical component n cos theta, and second component that is called as horizontal component, that is n sin theta, which is directed towards the center. And this n sin theta, n cos theta, which is called as vertical component, and n sin theta which is called as horizontal component. Now this vertical component which balances the weight of that vehicle. So we can write that equation, n cos theta is equal to mg. Why we write this equation? Because the weight of that vehicle is balanced by this vertical component, and that's why we can write n cos theta is equal to mg. Now second component of that normal reaction, which is directed towards the center, and that's why that provides the necessary centripetal force for the circular motion of that vehicle, and that's why we can write the second equation n sine theta is equal to centripetal force. But already we know the centripetal force formula for that, mv square upon r. This is the centripetal force. Say this equation number second. Now divide equation 2 by 1, we get n get cancel here, that is sine theta upon cos theta, or n sine theta upon n cos theta, n get cancel, is equal to mv square upon rg, mv square upon mrg. We can say that mrg, get cancelled. So sin theta upon cos theta is equal to tan theta. So tan theta is equal to phi square upon rg, phi square upon rg. So most safe speed on a banked road is given by the formula phi square is equal to rg tan theta, or phi is equal to under root rg tan theta. So this is the most safe speed, that is not minimum or maximum, but that is the most safe speed on a banked road, and that's why we write that equation phi is equal to under root rg tan theta. Or second, we can say that another is the, what about the banking angle, or what is angle of banking, that is theta is equal to, we can get the another expression for theta. Theta is equal to, already we got this equation phi square, or this equation v is equal to under root rg tan theta, or v square is equal to rg tan theta. Therefore tan theta is equal to what? Tan theta is equal to phi square upon rg. So theta is equal to what? Angle of banking. Theta is equal to tan inverse, tan inverse of phi square upon rg, tan inverse of phi square upon rg. By using this formula we can determine the angle of banking. So third point in that, what about the speed limit? Speed limit. Now already we discussed about the, this is the most safe speed which is given by the formula phi is equal to under root rg tan theta. This is the most safe speed of that vehicle, but now we are finding that minimum phi 1, that is phi minimum, minimum speed, minimum safe speed, and phi 2, that is the maximum safe speed. So in that case, when we discussing about the minimum speed, so in that case we can say that phi 1, that phi 1 which is less than under root rg tan theta, because already we know that this is the most safe speed of that vehicle on a banked road. Or we can say that this centripetal force m phi 1 square divided by r, which is less than n sine theta. Why you write that n sine theta? Because that n sine theta which provides this n sine theta, which provides the necessary centripetal force. So we can write here m phi 1 square upon r. Phi 1 means that is the minimum velocity, minimum safe velocity we are calculating. So m phi 1 square upon r is less than n sine theta. We got this equation. So in this condition, what about the frictional force? Suppose this is the horizontal road and this is the banked road, this theta, angle theta, and this is the vehicle. Suppose this is vehicle. So first force in downward direction, already we know that mg. Second force perpendicular to the banked road, that is normal reaction, and these are the two components of that, that is n cos theta, and second component, that is n sine theta. So in this condition we consider the frictional force. So frictional force means what? Force of static friction, that is the friction between the, force of static friction between the road surface and tires. So in that case the static friction which is along this bank road surface, that is Fs, force of static friction, which is along the inclination, we can say that along the inclination. And so this force also resolve into two mutually perpendicular components, that is the first component that is called as horizontal component, that is parallel to the n sine theta, opposite and parallel to n sine theta, and that component, horizontal component, is Fs cos theta. And second one is the vertical component, that is Fs sine theta. These are the two components of this frictional force, and that's why we can write that equation as, this is mg, weight of that vehicle, and there are two components, this is Fs sine theta, this is of that frictional component or vertical component of frictional force, and second one n cos theta, that is the vertical component of normal reaction. That two components which balances that weight of vehicle, and that's why we can write that equation as mg, weight of that vehicle, is balanced by n cos theta plus second component of frictional force, that is Fs sine theta. Say this equation number 1. Now the second, the necessary force for the circular motion of that vehicle, which is provided by n sine theta. And what about the this horizontal component of frictional reaction, that is opposite to n sine theta, and that's why we can use that equation, or we can write that equation as, this provides the necessary centripetal force. So centripetal force mv square upon r is equal to, that provides n sine theta. And what about the second component, that is a horizontal component of static friction, that is opposite, or this is, we can say, centrifugal force in that direction, go away from the center. So we can write minus sign here, minus Fs cos theta. Say this equation number second, mv square upon r is equal to n sine theta minus Fs cos theta. That is the equation second. Now for the minimum possible speed, phi s is maximum and is equal to mu s into n. For minimum possible speed, phi s, minimum possible speed, Fs is maximum, Fs is maximum, and that is equal to the mu s into n. So by using the two equations, and that's Fs is equal to mu s n, we can directly get that phi minimum, phi 1, or we can say that phi minimum is equal to under root rg in bracket tan theta minus mu s divided by 1 plus mu s tan theta. By using that relation, or by using this equation, we can determine minimum safe speed on a banked road for mu s, which is greater than or equal to tan theta. In that case, phi 1 or phi minimum is always equal to 0, and this is true for most of the rough roads banked at a small angle theta. This is the first condition, or by using this formula we can get the minimum safe speed on a banked road. So same way we are going for the maximum safe speed, that is we can write there phi 2 or phi max. In that case also, if we consider this if phi 1 is greater than rg tan theta, same way we are considering here phi 2 is greater than. Now here phi 1 is less than, we write there. Now we have to find the maximum speed, or phi max. So phi 2 is greater than under root rg tan theta, or we can write m phi 2 square upon r is greater than n sine theta, because that provides the necessary centripetal force. So we can write n sine theta. So in this case also, Fs is the force of static friction. So this is horizontal road surface, this is banked road, this angle theta, this vehicle, weight mg, various force act on that. First force, weight mg in downward direction, then normal reaction which is perpendicular to the banked road surface, and this is vertical component of normal reaction n cos theta, and second which is directed towards center, that is n sin theta, second component, or that is horizontal component, we can write that. But in this condition, if in first condition we take the frictional force of static friction, that which is directed, or components of that, here also that force of static friction between the road surface and tires of that vehicle, which is along this horizontal or banked road, but that is in downward direction, in this direction. Here in first condition, that is in along the inclination of that inclination, angle of inclination. So in this condition also, that force act along the same, but that is in downward direction, and that's why the Fs, that also, which is resolved into two mutually perpendicular component. First component, which is directed in downward direction, that component is vertical component, we can say that is Fs sine theta, and second component, that is Fs cos theta. These are the two components of that frictional force. So in this condition, that frictional force and n sine theta, that is both are directed towards the center, that means that provides the necessary centripetal force, or we can say that balances the centrifugal force. We can say this another way, Fs cos theta plus n sine theta, which balances the centrifugal force. And these are the, this another component, that is Fs sin theta, which is in downward direction. So same way we are taking here two equations, that is n cos theta, that is the vertical component of normal reaction, which provides the, or which balances that weight of vehicle, and Fs sin theta, both are in downward direction. So we can write that equation as n cos theta is equal to mg plus Fs cos theta, Fs sin theta, Fs sin theta, equation number 1. N cos theta, which is in the direction that balances the weight, and Fs sin theta, that also in downward direction. Therefore mg plus Fs sin theta, we can say that this equation number first. Second equation, in that case, second equation, that provides the necessary centripetal, these two components provides the necessary centripetal force, and that's why we can write mv square, mv2 square, we can write here mv2 square upon r, centripetal force, is equal to these two components, that is n sine theta plus Fs cos theta. These are both, these two components directed towards the center, and that's why we can write this equation second. So we got these two equations, first and second. Now in this condition also, the Fs is maximum, and that is equal to, Fs is maximum, and that is equal to mu s into n. So by using that three equation, first equation is this one, n cos theta is equal to mg plus Fs sin theta. Second equation, m v2 square upon r is equal to n sin theta plus Fs cos theta, second equation. And this is the third, that is the force of static friction, which is maximum, and that always equal to the mu s into n. By using that three equations, we can write phi2 or phi max is equal to under root rg in bracket tan theta plus mu s divided by 1 minus mu s tan theta. So we got the third equation, this equation for, that is phi max, that is a maximum safe speed on a bank road, and that is given by the formula phi max or phi2 is equal to under root rg in bracket tan theta plus mu s upon 1 minus mu s tan theta. And if in that case also, if mu s is equal to cot theta, then phi max or phi2 is always infinity. Okay, this is the next application of that. And for mu s is equal to 0, in that both conditions, if that coefficient of static friction which is equal to 0, then that both cases, that is v1, that is v minimum, and v2, v maximum, that is given as v is equal to, we got that first formula, that is v is equal to under root rg tan theta. That is the most safe speed on a bank road, already we calculate. And in that case, first we calculate phi1 or phi minimum. Phi1 or phi minimum is equal to, what is difference in that, under root rg tan theta plus mu s here, but in that minimum, phi minimum, minus sign is here and here plus sign is there. Phi maximum, in that case, under root rg in bracket tan theta plus mu s divided by 1 minus mu s tan theta. These are the uh, three equations for the that bank road, that is a maximum safe speed, minimum safe speed, and most safe speed on a bank road. This is the third application of that bank road. Now the next is the fourth application, conical pendulum. Conical pendulum, this is the fourth and last application of uniform circular motion. What is conical pendulum? Already, what is pendulum? Definition of pendulum: a small or point object or point mass, we can say that the point mass which is connected to the, that point mass which is connected to the long massless, long massless, flexible, massless, flexible, and inextensible, inextensible, inextensible string from the rigid support, rigid support, that is called as pendulum. What is pendulum? That is the point mass, or we can say that in a, that is the bob. Okay, point mass means bob, that is connected to the long massless, flexible, and inextensible string from the rigid support, that is called as pendulum. That is the definition of pendulum. Now, what is simple pendulum? When that pendulum which is oscillates vertically, then that is called as simple pendulum. Already we know that the definition of that simple pendulum. What is simple pendulum? When we can say that already we first we take the definition of that pendulum. Second, simple pendulum means what? When that bob or that point mass which is oscillate in a single vertical plane, then it is called as simple pendulum. Now we move towards the, what is conical pendulum. Why it is called as conical pendulum? If suppose that point mass or that point object which performs the horizontal circle, suppose this is the rigid support, and suppose this is the length of that string, L is the length of that string, this is semi vertical angle, okay, that performs the horizontal circle. In this condition, that is called as conical pendulum. That means it performs a uniform horizontal circular motion. In such a case, the system is called as conical pendulum. So we are discussing about that conical pendulum. Suppose M is the, or mg, which is the weight of that bob, mg, okay, weight of that bob, am is the mass of that bob, that means mg is the weight of that bob. So in that displaced position, if suppose we are considering this b position, at this b position various forces act on that position. That is first force which is act on that, that is the weight of that bob which is in downward direction, mg, which is in downward direction. And second force exerted at this position, that is tension T in upward direction, tension T in upward direction. Here also that tension T can be resolved into two mutually perpendicular components. First component, that is T cos theta, which balances the weight of that bob, and second component which is directed towards the center, that is T sin theta. These are the two components of tension in the string. So by using this relation, we can write first relation as t cos theta, that is the vertical component which balances that weight of vehicle, and that's why we can write first equation t cos theta is equal to mg. See this equation number 1. And second equation we can write there, that is the horizontal component t sine theta, t sine theta is equal to mr omega square. That is the centripetal force, or we can write mv square upon r, or this is also formula for centripetal force. So t sine theta is equal to mr omega square. So this is equation number second. Now dividing equation 2 by 1, what we get? Dividing equation 2 by 1, so we get t sine theta, t sine theta divided by t cos theta is equal to, t sine theta is equal to what? Here t sine theta is equal to mr omega square, and t cos theta which balances the weight of that vehicle, so we can write mg. T get cancel. Okay, so we get also get cancel. So omega square is equal to what? That is g sine theta divided by this r cos theta, r cos theta. So omega square, this omega square is the goes here, g sine theta divided by r cos theta. Omega square is equal to g sine theta upon r cos theta. Now r is the radius of that circular track or circular motion. R is the radius, and r is equal to l sine theta. Already we know that this is the angle theta. Theta is equal to L is the length of that string. So theta is equal to, we can write here, this is the this side, so r is the radius. Here r is the radius, so we can write here theta is equal to r upon L. Cos theta is equal to, so sin theta is equal to, r upon L. Sin theta is equal to r upon L. So r is equal to what? R is equal to L sin theta. So by using that equation we can write omega square is equal to, or omega square is equal to g sin theta divided by, instead of r we what we write, r is equal to L sin theta. So L sin theta into this cos theta. Sin theta get cancelled, so we get omega square is equal to g upon L cos theta. Or what is omega? Omega is equal to g upon L cos theta. Already we know that omega is equal to what? Omega is equal to 2 pi upon t, or is equal to omega is equal to under root. Omega square is equal to g upon L cos theta. Here omega means under root. So omega is equal to, another formula, omega is equal to 2 pi upon t, or is equal to under root g upon L cos theta. G upon L cos theta. And that's why we can find out the period of that. T is equal to, period of that conical pendulum, T is equal to 2 pi under root L cos theta upon Z. Or from that we can find out the frequency of that. Frequency is equal to reciprocal of time, and is equal to 1 upon t is equal to 1 upon 2 pi under root G upon L cos theta. This is the frequency of that. This is period of conical pendulum. Period of conical pendulum is given by the formula T is equal to 2 pi under root L cos theta upon G, and frequency N is equal to 1 upon 2 pi under root G upon L cos theta. This is the formula for the period of conical pendulum and frequency of that. Then the next point, that is a vertical circular motion, that we take on next lecture. Thank you.